Okay, everyone, this is us on the final video on section 2.6. We're going to be looking at what are called odd and even functions. So let's start off with the definition. An odd function is a function that is the same shape after you have rotated it 180 degrees. Some people might say it's sometimes called half-turn symmetry, right? You turn the shape upside down, essentially. To give you an example of what that would look like, here is an example of an odd function. If you take this function and you rotate it 180 degrees, do you see it's the same function? That is an odd function. Now, not all functions are odd. For instance, this guy here. If you take this shape and you rotate it 180 degrees, do you see it doesn't look the same as the original? Right, the original's here, totally different quadrant. This is not an odd function. So I'm going to give you, I'm going to draw some random graphs, some of which will be odd, some will not. And let's see if we can identify the ones that are odd functions and the ones that are not. Well, this is not an odd function. If you take this shape and you rotate it at the origin 180 degrees worth, see it's upside down there. It's not the same shape. If you take this one on the other hand, and you do 180 degrees, same shape. Same shape. So this is odd. Okay, what do you think about this one? Do you think this would be odd or not odd? Well, you can check it, but it is odd. And this one is a trick question. If you take this shape, and I'm calling it a shape right now, and you turn it upside down, it's quite clearly the same shape. So why is it not an odd function? It's not an odd function because it's not a function. So to be an odd function, you have to be a function to start with. Then you say, well, why is that not a function? If you do what's called the vertical line test, for a given value of x, you see how there's two values of y. That's not allowed. function for any given x, there should only be one y value, if any at all. You're not allowed two. So there is an odd function. That's what they look like. Now, what does an even function look like? Well, let's try that again. Get some more paper. Here we go. It's a definition of an even function. An even function is a function that has the y-axis as an axis of symmetry. So if you have a function and you can reflect it in the y-axis, so you imagine the y-axis and the reflection, that is an even function. So if you have a function that can be reflected in the y-axis, it is in fact called an even function. So remember this guy who's not odd, which he clearly isn't odd, but isn't it even? Do you see that if you reflected it in the y-axis, this is not even, this is not odd. It's an even function. These are two odds. This one is not a function, and it's not even either. Why is it not even? Because the y-axis is also an axis of symmetry in this shape, and actually a circle's got symmetry all over the place. It's not a function. That's why it can't be an even function. So what else do we need to talk about? Well, if you are given a function and you would like to know, is it odd or even, or neither? That's the other possibility. It's neither odd or even. So you could get a function that's even. You could get a function that's odd. Or you could get a function that's neither. So a function like this, and then like that. It's neither. Is there a way to tell by only looking at the function? See, what you could always do is you could take the function, right? And you could just put it into Desmos and look at it, and you should be able to tell if it's odd or even or neither just by its graph. But how do you tell, without doing that? Well, you can actually do it. There's a little test for it. So let me show you the odd even test. The odd even test for a function. If f of negative x, that's this guy here, is the same thing as f of x, then your function is even. If f of negative x is actually a negative of the thing, then your function is odd. And that's your test. And if neither of these is true, then I guess it will be a neither. How does that work in practice? Well, some of the most likely questions you're going to get are polynomials. So suppose you had 3x to the 4 plus 5x squared. plus 3. Now, we do not care what those coefficients are. In fact, let's pretend that's 30. They can be odd numbers, they can be even numbers, it doesn't matter. What we are interested in are the powers. The power of this guy is 4. The power of this guy is technically 2. And I know you don't have a power there, but if you had to, you could kind of artificially call it x to 0. So this here is a power of 0. And if all the powers are even, and 0 counts as even, if all the powers are even, then f of x is an even function. And that might make a little bit more sense now for why we call them odd and even functions. I suppose I had a different guy, and it was 3x cubed plus 4x. Again, we do not care what those numbers are. They can be odd numbers, they can be even, it doesn't matter. What we are interested in is power of x is 3 and the power of x is 1. And if all the powers are odd, then your function is an odd function. So you can use this test for polynomials. Just look at all the different powers of x. If all the powers of x are even, you are looking at an even function. The y-axis will be an axis of symmetry. You could put it in your Desmos to verify it, but it will be. If all the powers are odd, then you have an odd function. And of course, if you have even powers and odd powers, right? So this is 2, this is 1, then you will have a graph that's neither odd nor even. It's just a normal curve with no particular symmetry worth talking about. And that is us finished our 4th and final video for section 2.6.